everybody, and welcome. Here we are. This is the review show for September, 22nd through the 26th. And if you're watching this live, if you have any questions, you can tweet them to @WindsorChem, and I will be able to see them hopefully pop up. We're trying a couple new things here. Or if you have questions, you can text them to 607-205-8577. I'll get the text and I'll try to answer your question. First things first here. We need to come up with a name for this show. It's just the review show, and I guess that could work, but if you have a clever name, tweet it to @WindsorChem, or you can either text it to 607-205-8577, or email it to me at rbray@windsor-csd.org, and maybe I'll throw a little something your way if I like your name and decide to use it. So name for the show. Let's see, this week's topics. First thing we did was Lab 1 and Lab 2. Lab 1 was kind of a welcome to the lab room and safety and first aid and that stuff, and you signed a little contract that had to do with that. Lab 2 was the identification of laboratory equipment, where we took 15 commonly used items. You told me what the name and the use was. Life was good. Those were both due by the end of the day today, so hopefully, did I glitch? There we go. Hopefully you already turned those in. If not, technically they are late. If you were not here for those labs, the makeup is going to be October 1st. That's Wednesday, this coming Wednesday. After school, you'll get an extension on the deadline. Obviously, it's not a problem. But the makeup for Lab 1 and Lab 2, Wednesday, October 1st, after school. From there, we went on to talk about classification of matter. I got to move some things around here. We were talking about the basic elements, compounds, and mixtures. It all started with elements. Now, there we go. Elements are the simplest basic building block of matter. Elements cannot be broken down by chemical or physical changes, right? Reactions, and they're made up of one and only one thing, like hydrogen or like oxygen or carbon or any element you can think of, but it's just one thing. That's what elements were all about. We also talked about compounds. Compounds were two or more different elements. Remember, they have to be elements chemically combined, so they're bonded together. And what else? So they can be chemically separated. With compounds, we said that every single molecule, every single piece has to be exactly the same. So even though it's made up of different elements, each piece is exactly the same. And that's why elements and compounds were both called pure substances, because no matter where you get it from, no matter how large the sample is, every single piece of the sample is exactly the same. If it's an element, every single little thing is that element. If it's a compound, every molecule is constructed exactly the same way. It has the same ratio of atoms. They all look exactly the same. Pure substances, elements, compounds. The third one we talked about was mixtures. Mixtures are a physical combination of two or more different pure substances. So you're either combining elements, you're combining compounds, or you're combining elements and compounds. Again, it's a physical combination, so they can be separated physically. Now, mixtures, we said within that, there's two different types. There are homogeneous mixtures and heterogeneous mixtures. Remember, we talked about the prefixes homo and hetero from like biology with homo and heterozygous. Homo means the same, hetero means different. So you can use that to remember the difference between those. Keeping in mind, a mixture has to be made of different stuff, right? Mixtures have to be made of different things. So a homogeneous mixture is different stuff, but it's all mixed up evenly enough that it all looks to be the same thing. Like when we took that blue food coloring and mixed it all up in the water, you can't tell the difference between the food coloring and the water. Even though it's different things combined physically, it all looks the same. It looks like one thing. Homogeneous mixtures, different stuff, looks all the same because it's mixed evenly. Heterogeneous mixtures, however, you can tell the difference. Like the sand and the water that we had. You can tell the difference between the sand and the water. They're different things combined, and they look different. From there, we went on to look at homework page 3, which had pictures of these different elements, compounds, and mixtures. And theoretically, I should be able to show you that, but I can't. So let's see what's going on here. Please excuse this minor technical difficulty. There we go. Now we're cooking. I love a parade. There we go. Bam. Okay. Share. There. Now you can see what I see. So here are some different picture representations of what's going on. And we're kind of going to figure out whether these are elements, compounds, or mixtures. Sorry about the mouse there. So what's going on here? I'm missing something. Hang on a second. There we go. Okay. So with this first one, when I look at this, I can see that there's just one thing, right? This, and this. They're all exactly the same. And it's just one thing. What that's leading me towards is this is an element. Okay, so that's one way to show an element. It's pretty straightforward, no big deal. It could get a little bit more complicated. This is also an element. Now you may say, yeah, but here, these two things are bonded together. Right, but it's still just one thing. Both of them are exactly the same thing. And when you look at all of these, it's just one thing, right? Remember, the way we show different things in chemistry is either different colors or different shapes. And yes, again, these are touching each other, okay? But since it's just one color, it's just one element. All right. So, ooh, hang on, got a notification. Let's see what's going on here. Ooh, I like that idea. We got some we got some names for the show. I like this. Keep coming with those. And thank you for watching. So this one here, now immediately I can rule this out as being an element. The reason it's not an element is because I have two different things. I have white things or blank things and filled in things. So as a result, this can definitely not be an element. This happens to be a compound. And that's because it's made of different stuff. It's made of filled in things and not filled in things. But when you look, they're exactly the same, right? Two white things with one filled in thing. Two white things with one filled in thing. This is the same as this. It's a compound. Excellent. This is also a compound, right? Again, this and this are the same thing. They're facing in different directions, but again, it's a compound, right? Two or more different elements combined together, they're touching, and every single thing is exactly the same. Sweet. So that gave us elements, that gave us compounds. Now, of course, let's take a look at mixtures. This is a mixture. With pictures, maybe in a second I'll show you heterogeneous, homogeneous, but let's just focus on this for right now. I have two or more different things. I have white things or blank things and solid things. Okay, cool. But not everything is the same. This is very clearly different than these two things, right? So kind of the way it works, if I change ink here, this is one compound and this is another compound. But not everything is exactly the same, and that's why it's a mixture. You'd probably be okay figuring that one out on your own. This one's a little bit trickier, and this is usually one that throws students off. So if I asked you, what is this? An element, a compound, or a mixture? Some people may say, well, everything's all white. It's just one thing, it's an element. Nope. You may say, okay, it's a compound, because nope, not a compound. Because take a look, right? This, and this, that's the same. Those are compounds. That's one compound. However, that was a horrible choice of ink. There, yeah, okay. That's different. So this still is a mixture, and I'm making very bad ink choices. Mixture. right? Because it's different stuff. Now, how to tell heterogeneous versus homogeneous? With pictures, the way it usually works is if I do something like this, and you saw this one was on that homework page 3, if I do like this, and then this, that is an example of a homogeneous mixture. All right, let's see if we can get that in there. Homogeneous mixture. Why is it a mixture? Because not everything's the same. Wait, oh my gosh, this is totally wrong. This isn't homogeneous. I hope you were yelling at me going, that's not homogeneous. That's heterogeneous, because you can tell the difference between that stuff and that stuff, right? This is kind of like when I took the food coloring with the water, and you could see, bad choice, you could see the strands of food coloring. Sorry about this.
Please call 8215.
There we go, sorry. I can't really control that. That's kind of like when I had the food coloring going through. You can tell the difference between the water and the food coloring. It's different stuff that looks different, heterogeneous. Homogeneous might look something like this. There you go, right? That one really is homogeneous. Yes, mixture. And that's because it's nice and evenly mixed. And that's like when I had the food coloring, and then better yet, watch this, ready? I'll be super sneaky. And when I mixed it all together, you couldn't tell the difference between them. It all looked the same. Homo, same. Hetero, different. Boom, shalak, lock, boom. Okay, let's come back to me. Here we go, there we go, excuse me. So, awesome, that was elements, compounds, mixtures, and then heterogeneous versus homogeneous mixtures. Phenomenal. From there, we went into physical versus chemical changes. The big deal with that is that a physical change is one where you don't make a new substance. So like melting, evaporating, freezing, crushing, all those things. And again, keep in mind, melting is a little tough to work with sometimes because you think about water, and we have different names for water in different phases. We call solid water ice, we call liquid water water, and we call gaseous water steam or water vapor, which is a little bit closer. But when you call it ice, water, and steam, you might think it's different stuff, but all of those are all still water. So a physical change like melting, you're going from solid water to liquid water. It's still water. A chemical change is when you make something new. So like burning, you're definitely making something new. If you think about when you burn a log in your fireplace, you start with wood and it burns and you end up with ash. Pretty straightforward. That is chemical reaction. You may not know what the things are, but it works. Rusting iron is another example of a chemical reaction. You may say, yeah, but you start and end with iron. That's not technically true. The pure iron reacts with the oxygen in the air to make iron oxide, which is a chemical compound. So it actually does change. And we also talked about chemical versus physical properties. And same idea with that one. A chemical property is one that when it's observed makes a new substance. And a physical property is one that when it's observed doesn't make a new substance. Like I said, it can get a little weird when they say things do not do something, like something does not smell, or something does not have a color, or something does not burn. If you're ever confused with that, whether something does or does not, the property is still the same. It's still either a chemical property or a physical property. It's not that if it does it, it's chemical, and if it doesn't, it's physical. It doesn't work that way. So if you ever are confused when they give you a negative statement, like the one I said is, the chalkboard does not burn. just flip it. Because regardless of whether it's not what you're doing, it's the burning. That's the property. So what if it did burn? Well, I'd make a new substance, chemical property. So if you're ever a little concerned, just make it a positive statement. Make it true, even though it might be false. Make it so that it's a true, a positive statement, and that may help you. We'll see. But that was it, right? And then from there, I got food dye on my finger. From there, we went and did lab number 3, which was the physical separation lab. Some of you wrapped that up today. Some of you are going to wrap that up on Monday. When we come back, you'll get your final mass, and life is good. I love bells. So where that takes us to, because that's everything on my note card, where that takes us to reminders. Some reminders I got here for you. First off, the Unit 1 exam is coming up. For Mods 2 and Mod 6, the unit exam is going to be Tuesday. For Mods 4 and Mod 8, the Unit 1 exam is going to be Monday. So you might want to prepare for that. Don't forget, you can go look at the Google Drive. In fact, let's see if we can do that now. How do I go see the Google Drive, Mr. Bray? Well, here I am somewhere at my the school's website. I can go to our schools and then down to the high school. I can go to high school staff. I can go to my name. And then I can scroll down and look at my amazingly awesome web page, and you'll see right here it says Google Drive. If you click on that, it takes you to the Google Drive. Furthermore, you can look in Unit 1, and boom, there are some review videos for you. Holy cow. Those are going to be up for the entire year, and you're going to see those for every single class. Another thing that you can do if you want, I hope you can read this, you can enter in a web address that is bit.ly/chem, folder. I can't do this. Folder. There we go. bit.ly/chemfolder, capital C, capital F, and it takes you to the same place. I just used bit.ly as a link truncator to get us there. So you can either get there from going to the school's webpage, or you can get there from that link. Or if you email me, I'll give you Drive access directly, and you can access it from your own Google account or the app. But you can go there to get review help. Lab number 3, which was the physical separation lab, the salt and sand lab, that is probably going to be due on Friday, October 10th. So you want to check in Google Drive under the shared lab data folder. You can either click the shared lab data folder off the website, or in Drive, go to the 2.0 folder, go to labs, and then the shared lab data folder is in there. In there you can find, in fact, why don't we just go look? You can find, here we go, right? Regions Chemistry 2.0, labs, and when you get in there, you'll see shared lab data right here, and there we go. Aha, the lab procedure templates. You have to write a lab procedure for lab number 3. These are both the same file. One is a Word document. The other is a Google Doc, depending on how you're working. Whoa, I lost my lights. There we go. So either one of those can get you there and help you get the answer. Again, that lab is going to probably be due on Friday, October 3rd. Also, we have a poster contest. The local ACS, the local American Chemical Society chapter, is hosting a poetry poster contest for National Chemistry Week. The first place prize, you would be competing 9 through 12. The first place prize is a $25 gift card to Barnes & Noble, and second place prize is a $15 gift card to Barnes & Noble. You can also find information on that in Google Drive. So hey, let's go take a look, right? I lost it. Where'd it go? There we go, sifting through things. When you go to Regions Chemistry 2.0, you'll see right here in the Google Drive is poster contest information. There is the entrance form and an informational flyer. It tells you everything you need to know, how to send the posters in, what format they have to be in, all that great stuff. And that, again, is in Drive. So with that wraps up everything for me. Again, if you have any questions for me, because this is going to go straight to the YouTube channel, you can email them to rbray@windsor windsor-csd.org. Otherwise, here, I'll leave that up for you for a second. Otherwise, you can just come and talk to me, ask me questions, fire away. You can always tweet any questions down to @WindsorChem. I'll get back to you as soon as I can. And again, just a little maybe bonus offer there. Oh my gosh, I almost forgot. Don't forget about the Bluestone Cafe Trivia Question of the Week. Every Friday morning, I post up a trivia question to Twitter. It also gets sent to Facebook, but really Twitter is your best way to go about this one. So @WindsorChem, you wanna subscribe and follow that one. But the Bluestone Cafe has been very generous, and they are sponsoring our Friday trivia question. So it's called the Bluestone Cafe Trivia Question. I ask a trivia question every Friday. The first 3 replies that are correct win. The very first correct reply gets a free item from the Bluestone Cafe. Very, very nice. The second 2 responses that come after that, so the second person and the third person that correctly answer the question, you get a little bit of bonus credit in the class. It's not a ton, it's a little, but hey, it's something. So you wanna try and be first. It comes out every morning on Friday, every Friday morning, right around 8 o'clock. That way you can check it out. And the Bluestone Cafe being very generous, at the end of the year, the person with the most top 3 answers, meaning they're one of the top 3 finishers. Whoever gets the most of those, you're gonna get kind of a big prize from the cafe. They've already promised us a nice little prize. So that's awesome. So don't forget, check that out. If you got any questions, tweet me, email me. I gotta go, my daughter's waiting for me. See ya! Doo-doo-doo.